Hey, this is Tom from Inspirational Metalworks, and in this week's video we're going to look at developing a handle for a new product that we are going to be releasing soon called the Tormach Squirt. So the first thing I did is I basically drew a bunch of circles. I knew that I wanted a very fluid look for this, and I wanted it all to be easily adjusted. So once I had everything laid out, it was time to do the cam, and so one of the things I love about Fusion is being able to flip back and forth between them. I did something different this time in that I used patterns. I haven't used patterns in the past, but I tell you, it really made life a lot easier. So I've still got some tuning to do and all of this, but here's the basics of it. One thing that I already know, from running a couple of these batches is that I'm not going to put it just in the vise like this. I'm going to put it on a pallet from here on out. And actually, I'd like to do double the amount. So I've got the room to do that. The process basically is, drill the holes. One hole is for a set screw. The other is actually the actuating mechanism for these things. And for you guys that aren't clear on what this is, it's a handle that goes on a clamp for weightlifting equipment. It holds the weights on the bar. And so, we've got to get this out. I won't bore you with all this stuff. This is all real time. I didn't do any, I didn't speed anything up. So basically, what I just got done drilling were all the holes for the 1032 adjusters, and now I'm doing the hole for quarter 20. So, there's a couple of different things. It came up in another video where I said I was using a deep drilling for this, and technically deep drilling is more than 8 times the thickness or the diameter. That's what this mechanism is called in Fusion when you're doing the cam, right? So when you're going in and you're drilling and then doing a full retract for chip evacuation. Now, one thing that I did, another thing that I noticed in all of this, and it'll be much more evident as we get a little further on, is the cooling, or sorry, the coolant is okay, but I really need to up my game on chip evacuation. It does fine for the drill. I had everything lined up, but as we get into this this first bit of the cam, which is a 3D adaptive pass, I start to get some chip buildup, and I actually had to open things up and move chips out of the way. The tool I ended up using for this is actually one of the tools that was donated from Niagara. So thank you very much, Dennis Noland from Niagara. This is the A345. It's a 3-flute, 3/8 end mill, and it just chews this stuff up. You'll see here shortly. You can kind of see it's collecting a little bit. Nice chips. I think on this one I was doing full diameter depth, so 375 deep, and I was doing I guess I did 5% on the width, and it sounded good. It was doing a nice job. I was doing everything at I want to say 90 inches a minute for this, so pretty good speed for the 440. And as you can see here, right, starting to get a lot of chip buildup. So I think what I'm going to need to do is just get some better, add a couple of coolant lines so that I can approach the chip evacuation from different angles simultaneously. Because what was happening is it was basically collecting in one spot. When I'd reach the ends on this, obviously since it's overhanging like that, there's no place for it to collect. But you can see where it's on the vise, it just collects quite a bit. So at this point, all the big roughing was done, and it was still on that same 3D adaptive pass. But it's coming in and cleaning up the tabs, the locking tabs. Now, one thing I don't like about the 3D adaptive is there's a lot of this, right? Hey, everything was already done. It's just going back through, and you might hear a little bit here and there, but mostly I was cutting a lot of air at this point. So while it is great for some things, I have to figure out a little bit more on how to use it, I think, because it's not always the best option. It's great from the fact that it was one cam setup, right? I click the button once, told it a tool, feeds the speed, and let it run. And it came out really well, but I'd like to try and speed this up a little bit, so it may not be the best option overall. for how I'm running the tools. Once we got all past this, it was time to do just some basic contours, right? So clean up. I had left 10 thousandths all the way around, and so I come around and do the outside contour, and then I clean up each layer. And this is where I was using some of the patterns. So as you can see, it's doing everything for the one piece, and then it moved to the next one. I think I can change that to look at the height first, do everything all at the same height. It might be a faster way of doing it. I'll have to decide on that and take a look at it. But I was pretty pleased with the overall quality, I think. And the one thing I didn't get on video, I didn't realize it, is the chamfering that I did on everything. So basically all the cleanup and deburring. And that's one other thing I've got to go back and take a look at, and we'll see this in just a second. When I was doing the chamfering, for whatever reason, the chamfers on the holes that I drilled did not line up right. But I already know how I'm going to fix that. So as you can see, I was pretty pleased with the finish and how it came out, but just those holes, the chamfer was offset to the left a little bit. So thanks again for watching, thanks for subscribing, and I'll talk to you again soon.